All right, welcome back. So we've just got a little bit of exposure to something known as the factorial. Also, we've got a little bit of an idea in our heads as to how we can start counting what's called permutations, where the order matters, be it runners in a race or books on a shelf or any kind of arrangement where the placements matter. You will have not a string of products or a string of factors being multiplied together where they're all the same, right? That was what we had for end of ER. That was what we had for, say, pins or passwords, where you could reuse the same thing every time. But with permutations, every time you use something, you cannot reuse it, assuming, of course, order matters and there is no repetition, like runners in a race or books on a shelf. And if there's no repetition, every time you pick something, the number of choices remaining for the next selection goes down by one because you've picked something. And so this process of multiplying stuff together is called a factorial. So a factorial of a counting number, so 3 factorial or 10 factorial, is always just the product of all the counting numbers less than or equal to the number in question. So 3 factorial, that's 3 times 2 times 1. 10 factorial is, well, 10 times 9 times 8 times 7. You get the idea. All the way down to times 2 times 1. 1 factorial is a thing. It's just 1. And then also, just because sometimes we'll need this, by definition, 0 factorial, that's also 1. Just go with me on this one. The short explanation is because we go down to the next number by dividing by the previous, and that's how we can do factorials. And so 0 factorial does have mathematical meaning. So with all that said, let's do a little bit of The Price is Right, trademark. Suppose that a TV game show has an audience size of 350 people, and we are calling down 4 of those 350 people down to play. So come on down. And we're going to assume order matters. Technically speaking, the order you're on the board matters for The Price is Right. So order matters here. And we're going to say repetition is not allowed. You cannot call the same person multiple times. So how many configurations are there? So again, as we've been doing, you could just kind of logic your way through it like we did with the runners in the race. For the first selection, there's 350 people in the audience. That one person comes down. Then they pick one more. So there's 349 out of that selection. Then there's 348, and then 347. And that's how many configurations you have per selection. So the total configurations for all 4 combined selections is the product of 350 times 349 times 348 times 347. And just for my students out there who are using WebAssign or even Pearson, a lot of the time you're going to be able to get away with just typing 350 times 349 times 348 times 347 into WebAssign or into Pearson even. It doesn't need you to crunch those numbers. It's a robot. It can crunch them. But if you do need to be precise and actually multiply those numbers out, I have done so for you here. As you can see, it's a pretty big number. There are 14 billion ways that you can have 4 people out of 350 standing to play The Price is Right. And now you know. Now, to be even more general, the way you can do this quickly, where you're doing some number of selections out of so many choices, order matters, no repetition, then this formula is going to be the go-to. You're going to have the product of all the selections all the way down and divide out all the selections you're not making. This is NPR. So I've got a few examples here. This is where we're going to stop this video. I would like you to take this time to work out what these values would come out to be. And again, NPR is saying I've got 10 things, I'm picking 3 of them. I have 1,000 things, I'm picking 1 thing. So see if we can work through these, and I'll show you the answers in the next video. See you then.